This course is based on SunFounder 3-in-1 Arduino kit sold on Amazon. Everything that you learn in this course is included in this kit. The course comes with tons of components and projects, all with instruction and video for smart car and other projects that you can use for school or home automation. You can purchase it from sunfounder.com. The kit also comes with full documentation, code download, learning projects with full explanation, wiring diagram, and the code that you can download. The link to purchase the kit and documentation is below the video in the description. Welcome to Arduino course by Robojax. Hi, in this lecture we are going to learn about number system and bases. The numbers that we use in our financial calculation and daily transactions is based on decimal or base 10. Because in Arduino we will be using a lot of hex value and also binary values. For that reason we need to understand this number systems and bases. So numbers are represented in different ways. For example, our decimal number, which is base 10, every 10 the numbers increase or change or increment. We go from 0 to 9, and after that, when it reaches 10, we go to the next place value. For example, these 5, 3, or 299, these are decimal number. And then we have base 2 or binary. Binary means 2 in two ways or two position. So we have either 0 or 1. Any number you want to represent, we will use 0 and 1. For example, 10100 is one value or a number, or 101 is another. So you have no choice of using other values, because all the calculation in computer and storage and actual calculations are done based on binary because of simplicity, 0 and 1. And then we have hexadecimal. Decimal, we said, is referring to 10, and hex means 6. So that is 6 on top of 10, that is 16. That's why we call it base 16 or hexadecimal. Hexadecimal goes from 0 to 9, and after that A, B, C, D, it goes up to F. And here A to E is a number, which I'm going to explain all of those. And then 1, 4, B, D is also another number. This is a hexadecimal number. And then we have octal. Octal means 8, and that's base 8. And the number starts from 0 to 8, and after 8 it increments back to 0 and up to 8. 8 in 8, base 8 is an 8 and 5, and then 14. This 14 is not equivalent of our own 14 decimal, which I'm going to show you how you can calculate that. We will start explaining with the base 10, which we use. This is a decimal, and for example, when we write 245 in decimal, how we have determined the value of this? Actually, we have, this is the first place of value, this is the second place of value, and this is the third one. And this number goes from 0 to 9, which is 10 different values. And after that, because it's repeating, we have to add here one more and then continue. And then when this one reaches up to 9 and this reaches 9, so it will be 99. After that, we have no more room to display, and we have no choice but to add one more, and this will be 1. So that's why we read 100. Now let's see what it means. First, the position 0, the position 1, the position 2. This 5 means, because it's base 10, put 10 and put the position at the power, and then multiply it by the value. Now any number to the power 0 is 1. That's the first thing that you have to remember. And then 1 times 5, 5. So we got 5 here. Then 10 to the power, because this is a position of this one, is 1. 10 to the power 1 is 10 times 4, because this is 4. That is 40. And then this is to the power 2, so 10 to the power 2 times the value is 2 times 2, that is 200. Now if we add them all together, this will be 245. That's why the value is 245. And now let's have a look at the binary or base 2. Base 2 is the same principle applies. We have 1 and 0 and 1, so this is a 101, a value, and the place or position starts from this side, position 0, position 1, position 2. Same thing, because this is base 2, we put the base as a 2 and then the position as a power. So 2 to the power 0, we said anything to the power 0 is 1, multiplied by the value 1, so we got 1 here. And then here, base 2 to the power, the position 1, that is 2 to the power 1 is 2, multiplied by 0, the value is 0. And here we have the position is 2, so base 2 to the power, the position 2, 2 to the power 2. Pay attention, this is 2 to the power 0, 2 to the power 1, 2 to the power 2, multiplied by 1, this is 4. If we add them all, we are getting 5. So this is actually 5 in decimal. And the answer, because this is in decimal, we have to show it at the lower right corner, a number either 8, 16 or 10. So this 10 means this 5 is base 10. So this is a decimal value. Now let's have a look at the octal. We have 164 or 164, but this is not decimal, this is octal, base 8. The position is the same as before, is 0, 1 and 2. And let's see the value. It goes from 0 to 7 and we don't have any other value. When this position reaches 7, we add 1 more here. And if you see here 1 and 4, then this doesn't mean 14. You will see it now. Now this is base 8, we put 8 to the power 0, anything to the power 0 is 1, multiply by 4, the position is 0, so the value is 4. And here 8 to the power 1 times 6, the value, this 1 is the position. Pay attention, 8 to the power 0, 1, and then the next one will be 2, and if we have more, we will continue. Times, so this value is 8 times 6, that is 48. And here 8 to the power 2, 8 is 64, 8 times 8 times 1, that is 64. If we add it all together, the value is 116. You see, now we are representing a number with lower value, and this 10 means base 10. So this is 116 of decimal value. Now let's have a look at the hexadecimal or base 16. Hexadecimal, hex and decimal, and we have 2BF. The position starts from the right, 0, 1, 2. It goes this way, and we apply the same rule. But before that, we have to know some values. The number starts from 0 to 9, and then we have A, B, C, D, E, and F, and each of these letters have a value. A is 10, B is 11, and C is 12, up to F is 15. So we have to keep this in mind and then go. For example, this F means 15. Now let's see. Because this base is 16, we put the base to the power of the position, 16, anything to the power 0 is 1, times this F is 15. So this means 15. And for B, 16 to the position 1 times B. The value of B is 11, so this B is 176 at this position. And if B was here, this would have been 11. And now 2, the position of 2, so 16 to the power 2, that's a position, multiplied by 2, the value, and this is 512. Now if we add them together, you will see that we got 703. And this is base 10. I'm using the Windows calculator, and you can open it by clicking on the start and type calculator, and from here select programmer. It has so many other options for different purposes, but when you go for programmer, now you can see this bar on the left side of binary, we are in binary mode, and in binary we have only 0 and 1. For that reason, everything else have been disabled, and all of the numbers. So we can enter only 1 and 0. I can just do some random numbers, and it automatically calculates here the decimal value is 365, and binary is this. Now you can automatically convert it to octal, so 555, and in terms of hex it's 16D. Now pay attention here, let's go for hex. When we go for hex, A, B, C, D and F is also activated. Now if I use, pay attention here, if I use 3F, now look at the value. In terms of decimal, this is 4095. So with 3 values which can occupy 3 spaces, we can represent a number that goes up to 4000, while 4000, you can see, occupies 4 spaces. So that is the beauty of hex. You can represent a larger number with smaller few characters. And if I go further, these are like that, and you can see now it's already 16 million. But binary takes huge amount of space, and this is the way that data is being processed and stored in memory. So you can play with this calculator. Hi, this is an introduction to serial monitor. So what is the serial monitor? Serial monitor is a tool or a pop-up window embedded in IDE, Integrated Development Environment, the program for Arduino. This is a serial monitor. It's used for debugging, to find out the problem with a certain section of your code. It is used to print information from the code. For example, you're reading some data or a value or something. You want to make sure that data exists or does not exist, or is equivalent to some value. You print it and read it. And also it can read the user input from the serial monitor. Here at the top, the user can input the information, and it's used to read the serial port information of Arduino or from a PC. So it can read data from the serial port, for example, from USB or other means of serial. You can read the data using serial monitor. You can open serial monitor in 3 ways. The first way, let's start by clicking on Tools and Serial Monitor. As soon as I clicked, as you can see, there is a warning. It says board at COM13 is not available, and also the same information is here. It means my Arduino is not connected. So the first condition is that if you want to make the communication possible, you have to select a certain port and then connect it. This 13 that you see here is the last used port. When I was using, prior to this lesson, when I was using Arduino, I have used port 13, and Arduino has remembered that, and it goes to that port. And you can check the port by clicking at the tool port. As you can see, it has only COM3. COM3 is used within my computer in Windows for other purposes, so that cannot be used for this application that I'm running now. You run this, nothing will happen. Now I'm connecting my Arduino, and let's click on Tools and Port. Now you can see we have one more port, and that is the Arduino board that I have. So now let's open it. Click on Tool, Serial Monitor. So this is one way to open the serial monitor. This doesn't do at the moment anything. Let me close it and open it in a second way. The second way would be a shortcut, Control-Shift-M. Now if on my computer, if I press Control-Shift and M, it opens. And the third way would be to click on this icon. This is a serial monitor icon. You click and opens. So perhaps if you're using mouse, this would be your best option. If you're a person of keyboard, Control-Shift-M is the monitor or serial monitor. To initialize the serial monitor, inside the setup at this portion, as you can see here, we have one function here. It's called setup, And we have another one, it's called loop. The function is identified by this opening and closing parenthesis. And this is the opening and closing portion of the function, all the content that is inside the setup or within these two curly parentheses. So we will have inside the setup, we have to type serial.begin and opening and closing, and in here we type the speed of communication, baud per second. Here I'm typing 9600, and this baud must match. Open the serial monitor side by side. On Windows, click on this bar, hold it and go to the left of the screen, and it occupies half of the screen, the serial monitor value. And now click on this, the serial monitor opens wherever it was the last location. Now I'm holding again from the top bar, go to the right, and it shows you where it goes. Now the screen has been splitted. If you want to adjust it, if you grab from the middle, both of these will be adjusted to the left or right. I think this is enough for me on this side. After setting the baud rate in here, when you open your serial monitor, the serial monitor at this point at the right lower corner, you will be able to set the baud rate that matches this. If you set it in a different value, you will not be able to see the text, which I'm going to show you next. And here, let's print this text. If you want to print something on the screen, you type serial.print. And serial is a class name, and then dot, this is a method or function part of this class. Print is part of this class, and whatever you want to type, you will type it inside the opening and closing parenthesis here. And because I'm typing a text, for the text you must put double quotation at the beginning and end. Once you type it, you will not see it here until you upload it to the Arduino board. Arduino board is now connected and I'm uploading it. When I click this, the code is now uploaded to Arduino. Once that is completed, it will be printed here on serial monitor. And here, if I change the baud rate to the right lower corner, 19,200, you will see the same text is displayed like this. It's not readable. If I select a different baud rate, 38,400, you will see different character. Depending on the baud rate, the data that comes will be treated differently. See, when I upload the code, the serial monitor is grayed out, it's disabled. Once the code runs, you will see that Robojax and then welcome, they're shown in one line. The reason for that is when you type print, it will print this, and another print will come immediately after that. So you have multiple ways to fix it. One way would be to just put space here. You can delete this space and add the space before the welcome word. And there is also a third way. The way would be when you print this, we can say print the text and also print a new line for us, which means go to the new line. And this is happening like ln, and we type ln to do that. ln, that is new line. N is on this side, but that refers to new line. Now you see the Robojax have been printed and new line have been inserted, and then welcome appears in the other line. The same way, if you want something after welcome to appear in another line, add here new line. If I add ln here, you will not see any difference, because this ln creates a new line after the welcome. Whatever comes after this will be affected. And as you can see, this ln that is in the welcome line is affecting this line, and this doesn't have anything, and doesn't matter if I put here ln, it will affect the upcoming new text after this line. There are other ways also to add the new line. And here, as you can see, two Arduino class have been printed and name appears at the end. There is another way to break this in a new line. You can just add here \n. this backslash is a key on the keyboard. And here is a backslash location on the keyboard. In the US English, the location is here. In your region, it might be somewhere else, either with pressing shift or without shift, somewhere. This is escape character, and it is used extensively in programming. And here it tells the program that do not print this in, this is something special. So this is telling that the character that is coming next is a special character. And this backslash n means new line. It means create a new line. If I upload this, even though there is no ln, if I upload this, after this, the word class, you will immediately see a new line. So this name will go down. As you can see, after the class, name went down to the next line. And you can do backslash n anywhere in the text and break those texts. For example, if I want name to be here and telephone should be low and address should be lower, I can do the same thing. Backslash n, backslash n. The code. Now, once the code is uploaded, you will see that after the class we have a new line and n, and each will appear in a new line. And this time I've changed it. I've put here backslash t, backslash t. This t means tab. The address after this, I put last name, and here I put backslash n. That backslash n after the address creates a new line, and then last name is printed. After that, this backslash t means tab, like in any word processing program like Microsoft Word or Google Sheet. If you press the tab on the keyboard, it creates a certain space. So that's one tab space, and then we have another tab. So this is for tabular data. Sometimes you want to display some information in a column, you can use backslash t. So pay attention to this backslash t. In front of p, nothing happened because p is not a special character with backslash. So this backslash was not able to escape p and execute whatever p was doing because p was not in the list to do anything. Now backslash is also not printed. And here, if I want to print backslash, I have to put another backslash in front of it. So this is escaping, and it says ignore the job of this, and it is now printing one of them. This is how you can print a backslash. And if you want to print two backslashes, you have to put 4. This is how it prints also 2 backslashes. Now let's see how we can read user's input. And here this is the code that accepts the user input. And here is an example that we read user data. The serial monitor is here, and the code for the explanation, for simple explanation. And here simple explanation would be that we check if serial.available. This checks if the data is entered by the user because it doesn't print, you can see anything here. If it is available and it is greater than 0, then we print this. So we use serial print ln as before. Inside this, we just put serial dot read. So we type this inside this parenthesis. If I put some space, you will see it properly. So this was the opening and this is the closing. We just put here serial.read, and this is serial.print. So serial.read gets the data that we enter here, or the information. So this grabs it. We can do something with it, but in this case we just put this inside this print so it can print this for us. For example, if I type A, 97, if I type B, pay attention here, and C, 99. And if I print 0, 48, 1, 2, 49, 50. Then why it doesn't print A or B and C? The reason for that is this is not the A or B value. This is ASCII value for that, because valuing each numbers, each characters, we have associated number related to it, which is called ASCII, or ASCII. ASCII stands for American Standard Code for Information Interchange, ASCII, and it has a table defined by an organization in the US, and these are the values for different characters. These are printable values, and as you can see here, for a space we have 32, explanation mark. These are all characters that are in the US keyboard, US English keyboard. And as you can see here, when I typed A, it printed 97, for B 98, for C 99. These are the decimal value. And also here, when I typed 0, it typed 48, printed 48 for me, and for 1, 49, and for 2, 50, because these are ASCII characters that is being printed. So pay attention that serial monitor prints ASCII character if you just print it directly. And here I've changed the code. I've just added this in front of the serial read. This is called casting. Casting means changing a type of data into other data type, and inside open and closing parenthesis we just type char, C-H-A-R, or sometimes people read it as char, and this is converting this from the decimal value or a number into a character. Now if I type A, it will be A, B, C, all these readable characters that we have on the keyboard, and it will be printed. And here are some of the built-in examples of serial monitor. If you click on File, Examples, and then go to number 4, Communications. Let's first print this ASCII table. This is a program that prints ASCII table. And let me upload it. This program prints all the values of American English keyboard. From exclamation mark, it goes from 33 decimal, and as you can see, the number is increasing, and it goes to 126. Beside this, we have hexa value and octal and binary values, which I'm going to explain in an upcoming lecture. Let's open another example. If you click on File, Examples, Communication, Serial Event. Let's upload it. In this example, you have to enable from the lower right corner the new line. Once you enable it, when you enter the value, it collects it and prints it. For example, you can enter 2, 3 or more digits and it will be printed. This new line will send also a new line character with your entered value. This new line will send also a new line character with your entered value. If I print 1000, you see they are all printed together. If this code is not arranged this way, you will see that if I type 8798, it will be printed in separate values. If you remember from the first example that I gave for the reading, if you print 8, this just prints ASCII character. But let's print HY. As you can see, it prints 2 lines. The reason for that is that it reads each character separately. Y is 121. As you can see, if I type TY together and press enter, it prints 116 and 121. But in this example, it will be printed all together. If I print TY, it will be printed as TY. Without making it a character, it prints actual value. If I type 87, it will be 87. This was introduction to serial monitor. It can do much more than what I've explained. And as the course progresses, within the topics, I've explained more features of this. Thank you for watching.